Ben Franklin's World is a production of the Omohundro Institute.
The story that we in public health are always told in school is that Dr. Jenner was out on the British countryside and he saw these beautiful milkmaids who had no scarring whatsoever. And they were relatively older, in their 20s. And he was wondering why they didn't have the scars that every other person had, because most everybody caught smallpox. And he asked them and they said, we never had smallpox. And he asked their parents and they said, nobody on the farm got smallpox. And he said, well, have you ever had anything like smallpox? And they said, oh, yeah, we got the cowpox, from the udders of the cows, but that's about it. They just give us some pustules on our arms and they don't develop into anything more than that. And we don't get fevers and we don't get sick. And so Dr. Jenner says, there's something there. I'm going to study it further. So he performs these experiments. My name is Rene Nájera. I am a doctor of public health. I'm an epidemiologist. I am the director of the History of Vaccines project from the College of Physicians of Philadelphia.
Before its eradication in 1980, smallpox was the most feared disease in many parts of the world. Known as the king of terrors and the disease of diseases, the search for a way to lessen and avoid smallpox was on. As we investigated in our last episode, episode 301, the first major strategy for mitigating smallpox came from the world's first immunization procedure, inoculation. Inoculation involved taking the pus from a mild case of smallpox and either drying out that pus for inhalation, which was a practice of inoculation performed in Asia, or by taking the pus and placing it under the skin of a healthy person by means of an incision. In both cases, the idea of inoculation was to help a healthy person contract a mild case of smallpox so that they could go through the throes of the disease as easily as possible and emerge with a lifetime immunity to the variola or smallpox virus. Now, as the inoculation procedure required infecting healthy people with mild cases of smallpox, which not only made people sick, but contagious, some in the scientific and medical community of Europe started looking for a better way to keep people safe from smallpox. It was this quest for a healthier and safer alternative to smallpox inoculation that led to the world's second immunization procedure, vaccination, a procedure that received its name thanks to Dr. Edward Jenner's observation of how those who worked with cows and had contact with the cowpox virus seemed to develop an immunity to smallpox without ever becoming sick with either disease.
The smallpox vaccine is the very first vaccine. It's where we get the word for it. My name is Farron Yarrow, and I'm a postdoctoral associate in the Department of Gender, Sexuality, and Feminist Studies at Duke University. Next year, I will be starting a postdoctoral fellowship at the Omohundro Institute, where I'll be working on my first book, Atlantic Antidote, Race, Gender, and the Birth of the First Vaccine. The smallpox vaccine at the time referred to cowpox, and the word itself comes from the Latin for cow, vacca, and it's a term that Edward Jenner himself coined.
How did vaccination come about? What are vaccination's connections to smallpox inoculation? And how did news and practice of vaccination spread throughout North America? These questions will be our focus in the second and final episode in our From Inoculation to Vaccination series. To understand how the vaccination procedure developed and spread throughout North America, we first need to understand vaccination's connections with inoculation and how the people of British North America became more trusting of the inoculation procedure in their fight against smallpox. Our story of inoculation in British North America picks up right where we left off in episode 301, at the end of the 1721 smallpox epidemic in Boston, where the procedure of inoculation was first introduced to British Americans by an enslaved African man named Onesimus.
It's interesting how reports of Boston's epidemic bounce around. And so people in other cities are paying attention to it. They're publishing short notices of what happened in Boston, the numbers who are inoculating in their newspapers. I'm Andrew Werman. I'm an associate professor of history at Central Michigan University, and I'm writing a book that's coming out next year called The Contagion of Liberty, The Politics of Smallpox in the Revolutionary Era. Benjamin Franklin is probably the key figure that takes what's happening in Boston and publishes it in Philadelphia. Franklin was certainly very influential in Philadelphia, but also in London. He spent a considerable amount of time during his life in London. And Franklin created, or helped create, a sort of circle of American doctors who travel to London. They study with John Coakley Lessen, they study with John Fothergill, and these kind of Quaker doctors. So these Pennsylvania doctors, Massachusetts doctors, some from South Carolina. And Franklin is kind of the focus, providing introductions, letters of recommendation to these Americans. And after their education in Britain, they return to the colonies and continue to advocate for broad access to inoculation. And they keep up correspondence with one another.
Public opinion trended more favorably towards inoculation as the years went on, as social influencers like Benjamin Franklin, like George Washington, adopted the practice. In other parts of the world, Catherine the Great, who was a Russian Tsar, also heard about this wonderful thing and suggested that her subjects be inoculated. She herself was inoculated.
After the 1720s, smallpox inoculation was a procedure that many in the British Atlantic world and across Europe were beginning to adopt in their fight against smallpox. In many ways, the data collected by Dr. Zebdale Boylston during the 1721 Boston smallpox epidemic and published by Benjamin Franklin and his older brother James Franklin helped those connected to the English-speaking world see the benefits of inoculation, as did continued experience with smallpox epidemics.
Philadelphia has that epidemic in 1736. Charleston, South Carolina has an epidemic in 1738, and they try inoculation. The inoculation efforts get a little bit larger. In Charleston, over 1,000 people inoculate. The results again get published, and it's creating an overall demand for the procedure. The scruples of people are becoming diminished, and the question starts being, how do we give this to everyone? How do we provide access?
From the very beginning, we in public health get trained to look at the social inequities, because that is what drives a lot of these diseases, a lot of these epidemics are the inequities more than the viruses and bacteria themselves. So if you're a lower social class, even to today, you're more likely to live in congregate settings or in overcrowded settings, which leads to huge disease transmission. And the lack of access to healthcare, to inoculation, to somebody who knows how to do inoculation. So the lower socioeconomic level you are, then the less likely you are to have access to these things. And it repeats over and over again as the first vaccines come around.
As demand for inoculation grew, so did early Americans' need and desire for access to the procedure. Into the American Revolution, inoculation was often expensive and a smallpox preventative that only the wealthy and well-to-do could afford. The expense of the procedure came from the fact that those who took even a mild case of smallpox needed to be cared for with nurses and medicine, and they had to be quarantined for 3 to 4 weeks, which meant a lot of missed time from work. As a result, towns allowed individuals to build private inoculation hospitals and clinics with the hope that those who wanted the procedure could take it safely and without starting an outbreak. But pretty quickly, most town residents realized that private hospitals were out of reach cost-wise for many who wished to be inoculated. This is what happened in the town of Marblehead, Massachusetts.
Marblehead proposed building a private inoculation hospital. They're going to build it on an island off the coast, and because it's private, it won't cost the town any money. So they vote for it. They approve it. It gets built in October 1773. The first class of patients enter, and the average people of Marblehead realize fairly quickly that this hospital isn't going to help them very much. It turns out it's the most expensive hospital in the colonies. They charge for one inoculation about a quarter of what an average sailor makes in his best year of his life. Average people couldn't afford to go to Essex Hospital. They could see it, though, and the wealthy people who went there are having a good time. They're throwing parties, occasionally shooting fireworks, and it's just bugging the people in Marblehead who are still suffering with disease. Over time, some people from the hospital start leaving early. They start breaking quarantine and coming back early, and there are a number of altercations within the city. This is October, November, December 1773. At the same time, Marblehead is having these conversations about smallpox and who has access to it. Boston is having its debates over tea. And I discovered Ashley Bowen's journal, and I thought I would see what this average sailor thought of the Boston Tea Party. And Bowen says nothing about the Tea Party. It's all about smallpox and inoculation, as if he doesn't know that this imperial crisis exists. So in January 1774, about 3 weeks after the Boston Tea Party, sailors in Marblehead take matters into their own hands, but in a much rougher way than the Tea Party does. There are no patients in it at the time. They burn the hospital. It's valued at well over £1,000. I argue it's one of the more destructive events in the run-up of the revolution, but it's generally not included in textbooks, even though it was significant. Sam Adams writes about it.
Smallpox was ever present during the American Revolution. In addition to fighting the British Empire for their independence, revolutionary Americans also had to contend with smallpox and the way that the disease hindered the Continental Army's movements and fighting ability.
Smallpox was already there. When the first shots were fired at Lexington and Concord, communities throughout Massachusetts and New England more broadly were battling smallpox. Boston is isolated, almost an island. It's filled with soldiers and loyalists and people who are trapped inside this blockade, and smallpox does break out. In the occupied city, they're having trouble getting food, they're having trouble providing for themselves, and Thomas Gage, the general in Massachusetts, and then later William Howe, who takes over, start releasing ordinary Bostonians, poor people, from the city because they can't feed them. They're suffering. And George Washington thinks this is a nefarious plot by Thomas Gage to spread smallpox out of the city. And at first, Washington says he can't believe that they would do that on purpose, but reports keep appearing. Washington starts giving credit to it. He starts believing that the British military, that Thomas Gage is purposefully trying to spread smallpox out of Boston to infect civilians, to infect the Continental Army.
As Commander-in-Chief of the Continental Army, George Washington would spend much of the War for Independence waging two wars. One against the British for the independence of the United States, and one against smallpox, to keep his army and the American people alive. Smallpox posed a significant and lethal threat to both the people of the new United States and to its fighting force, the Continental Army. Believing that smallpox inoculation would do his soldiers more harm than good, Washington decided to pursue other preventative measures against the disease.
Washington makes this initial decision that his troops are just going to continue quarantining, trying to keep up sanitation, try to limit the communication and access between smallpox hospitals in Boston and the Army, to try to really inspect troops for any symptoms and get them out to the hospitals as quick as they can. But disaster strikes. A bunch of these New England soldiers launch an invasion of Canada in 1775 and into 1776, and smallpox breaks out among the troops in Canada. It is a disaster. It dooms that invasion plan. There's lots of blame going around. Soldiers try to inoculate themselves. They're aware of the procedure and what's necessary, but they try to inoculate themselves in secret. There are stories of soldiers blindfolding themselves before entering a tent where they're inoculated on their arms, and they're blindfolded because they didn't want them to see who was inoculating them, so they wouldn't rat them out to their superiors.
As the war raged on, demand for inoculation among soldiers and civilians grew. Most people were aware that enlisting in the Continental Army could mean death from smallpox instead of death from battle. Plus, soldiers often contracted smallpox in camp, and then unwittingly brought the disease to each town they marched through, as well as to their homes and families while they visited on leave.
More die from disease than in battle. They die in camps and in hospitals. The numbers are really difficult. It's difficult to determine who's dying of smallpox and who's dying of typhus or dysentery or other conditions. but it was a significant number of them. There's a congressional investigation, the first congressional investigation in U.S. history. The Second Continental Congress investigates what happens in Canada. The Canadian campaign fails because of smallpox. There's no other reason. Washington has more difficulty building his army in 1776, 1777, and later in the war, in part because of fears of disease. So it did affect that military strategy. Washington had to be vigilant at all times against it. And he just didn't really trust inoculation. He didn't trust inoculators. He thought they were often schemers and profit seekers. Meanwhile, the troops are all for it.
Even as soldiers, their families, and the communities that serve the Continental Army wanted soldiers to be inoculated for smallpox, George Washington continued his reluctance to consider the idea. As Andrew Wehrman pointed out, Washington didn't trust inoculation or inoculators. In 1776, when a group of Massachusetts officers applied to be inoculated, Washington accused them of being traitors to their country. But over the course of 1776, Washington began to soften toward inoculation because of his wife, Martha.
In 1776, his wife Martha goes and gets inoculated in Philadelphia, and Washington writes to her and writes to others saying that, he really doubts that Martha's going to go through with it. He doubts her resolve, and she does it and has a successful inoculation. Martha's inoculation probably opens him up to it a little bit. It's happening pretty broadly in Philadelphia. Members of the Continental Congress are getting inoculated. And so the demand is growing. Eventually, Washington hires onto his medical staff a celebrated inoculator. His name was John Cochrane. William Shippen, a prominent physician and professor of medicine in Philadelphia, is on Washington's staff, and they continue plying him. In February 1777, Washington starts writing this letter to John Hancock, and he says, look, I can't do it. We can't inoculate. It's not going to work. It would spread disease everywhere. And he ultimately crosses out that. The next day, he revisits that letter and he writes, you know what, let's do it. I think it's going to work. And he changes his mind, and he's stunned by the reaction. The doctors were right. The procedure works. The soldiers were all for it. There's no opposition among soldiers.
George Washington changed his mind about inoculation, largely because of pressure from his medical staff and because Martha Washington's inoculation procedure had gone so smoothly. Once Washington decided to go forward with inoculating his army, he attempted to do so as secretly as possible over the winter of 1776-1777. The result? Many soldiers and civilians were inoculated in winter encampments, and the Continental Army started its 1777 campaign season, no longer susceptible to the ravages of smallpox.
Washington, after seeing the success, becomes a huge advocate for inoculation, completely changes his mind. He writes to Patrick Henry in Virginia and says, I wish that we could pass a law requiring every Virginia family to inoculate their children. Washington has his family and his slaves at Mount Vernon inoculated, even though technically that was illegal in Virginia. He does it anyway. Washington does a complete about-face, a complete 180.
George Washington would continue to have all Continental soldiers inoculated before they joined up with the army. But disease continued to plague his soldiers. Although inoculation largely kept smallpox at bay, diseases like typhus, dysentery, and in the Southern theater, yellow fever and malaria, infected his army throughout the war. But even with these other diseases, by removing the threat of smallpox with inoculation, Washington and his Continental Army won the war, and the United States became an independent nation.
There's hope that comes out after the Revolution that the United States might be the first country in the world to eradicate smallpox. Outside observers, Europeans, doctors are in awe of how well Americans combat smallpox. There's a letter that Washington receives from a German doctor who says the United States is bound to become not only the first independent nation, but it's obvious that the United States will become the first nation to eradicate disease. Of course, that doesn't quite happen, or at all. Smallpox isn't eradicated until 1980, but there's a tremendous amount of hope from it that in just a few weeks' time, you could inoculate large populations of people and have them safe against this terrifying disease.
The mass inoculation of the Continental Army gave the world hope that eradicating smallpox was a distinct possibility. But the procedure of inoculation still carried a risk of contagion. People were infected with live smallpox, and they were contagious. The threat of smallpox outbreaks loomed large with each inoculation. So some wondered whether there might not be a better way to protect people from smallpox and eradicate the disease. One person who wondered about this was Dr. Edward Jenner, the father of vaccination. How did Edward Jenner's thinking on a better way to protect people from smallpox lead to vaccination? We'll find out right after we take a moment to talk about our episode sponsor. Enjoying the narrative style of From Inoculation to Vaccination? If so, you should join the Omohundro Institute and Mass Humanities for another 2-episode narrative series on Ben Franklin's world. It's called The World of the Wampanoag. On December 16, 1620, the ship Mayflower sailed into Plymouth Harbor and dropped anchor. Standing aboard this 236-ton ship stood 102 passengers and roughly 30 crewmen. Those settlers have been called Pilgrims, and 2020 marked the 400th anniversary of their arrival in New England. What happened when the Mayflower's passengers disembarked and came ashore? What kind of world did they find themselves in? In episodes 290 and 291, we explore the Pilgrims' new world, which was, and still is, the very old world of the Wampanoag people. For more than 12,000 years, the world of the Wampanoag has been a world filled with life, culture, and trade. It is a world filled with many indigenous peoples, and it was this indigenous world that the English colonists settled in and adapted to. So who were and are the Wampanoag, who lived and live around present-day Plymouth? Who are some of their closest neighbors, the Narragansett, who live to the south? And how did the Pilgrims adapt to living in a decidedly indigenous world? Join the Omohundro Institute in Mass Humanities for a special 2-episode series about the world of the Wampanoag before and after 1620. The Wampanoag's history has always been spoken. Hear it on Ben Franklin's World in episodes 290 and 291. How did Edward Jenner's thinking on a better way to protect people from smallpox lead to vaccination? Here's Dr. Renee Najera.
The first vaccine by Jenner was derived from the cowpox virus. Cows would develop these pustules in their udders, and anybody milking cows would get it in their arms, and they would be resistant to smallpox. And Jenner and others observed this.
At the time, people didn't necessarily understand the mechanism behind immunization. They didn't understand exactly why it worked, but they did understand that if you were infected with the fluid from these sick cows, when there was a smallpox outbreak, the people who had been exposed to cowpox previously did not get sick with smallpox. Edward Jenner is the first person to take this theory, to kind of take this kind of community knowledge and experiment with it. And so what he does is he extracts vaccine fluid, the lymphatic fluid, from a pustule on the hand of a woman named Sarah Nelms. And he uses that fluid to then make an incision into the 8-year-old boy, James Phipps.
Dr. Jenner wanted to try this out. And so Jenner went to Phipps's dad and said, "Hey, could I borrow your child for a medical experiment?" And so Jenner paid the father a certain amount of money and then used a little lancet to put the pustule material into James' arm and then observed James. James didn't get sick. He didn't have a fever. He got a blister where the inoculum happened, but nothing more. A few weeks later, Dr. Jenner gets smallpox, actual smallpox, from a woman who was suffering from it, and takes an inoculum. And by all accounts, this is serious smallpox. This is not just any smallpox. And he goes to James and lancets his other arm and gives him the full-blown smallpox. And then he waits. And nothing happens. Nothing at all. James doesn't even develop a pustule at the site of the inoculum with smallpox. He doesn't get sick. Nobody in his family gets sick. He's completely okay.
Edward Jenner goes on to do this with a number of different case studies. And then in his book, he publishes on this. And so very soon thereafter, his book gets translated, and knowledge of this makes its way around the globe. And people throughout Europe and throughout the Americas start to try to look for natural sources of this cowpox in livestock and try to find ways to circulate the lymphatic fluid out of England into Europe and make its way through the Atlantic world.
English men and women involved in dairy farming had long known that if they became infected with cowpox during their daily work routines, they were unlikely to contract smallpox when outbreaks occurred. So Edward Jenner wasn't the first to make the connection between cowpox and immunity to smallpox, but he was the first to actively experiment to prove this connection and the first to publish his findings so that everyone knew of this connection. Now, Jenner and other doctors in the 18th and early 19th centuries often used children as test subjects. For example, Dr. Zebdale Boylston of Boston used both his own young son and the son of an enslaved man to test inoculation during the 1720s. And as we just heard from Renee Najera and Ferraniro, Jenner's first test subject in his cowpox-smallpox experiment was an 8-year-old boy named James Phipps. Now, the use of children as experimental test subjects may surprise us, but ideas about medical ethics and the role of children in society were really quite different in the 18th and 19th centuries than they are today in the 21st century. Plus, we need to remember that smallpox was considered a childhood disease in Europe. So, in order to ensure that his test subjects had never had smallpox before, Jenner really needed to use young children in his experiments to see if his vaccination practice really led to immunity from smallpox. In fact, children were really the people who made the creation and transportation of the smallpox vaccine possible.
Typically today, right, we think about vaccines as synthetic substances that are developed in labs, but the vaccine at the time was a naturally occurring source. It wasn't necessarily developed, but it referred to either the lymphatic fluid, so like the lymph that could be harvested out of the pustules that would form on the udders of infected cows, or once the pustules scabbed over, the vaccine could also refer to the dried substances that could later be rehydrated. So doctors who were invested in trying to conserve and circulate this material were interested in trying to maintain the virulence of this virus, but also find a way to transport it in a way that it wouldn't necessarily get damaged. And that becomes a significant problem when you start trying to move the vaccine across the Atlantic Ocean.
The first true global public health intervention begins with the smallpox vaccine in 1804 with the Balmis expedition from Spain. They take the vaccine in children, much like you would do with inoculation. They take 30 or so orphan children from Spain, give one the inoculation at the beginning, and then pass it on in a chain all the way to the Americas. Then they basically vaccinated the entire Spanish Empire in the Americas and then on to the Philippines, traveled around the world. And when other countries heard of that happening, Portugal and England asked if Dr. Balmis and his crew could stop at their overseas territories and give that vaccine as well. But with inoculation, there's just no good evidence that it happened anywhere else but in the British colonies.
There were multiple vaccination campaigns throughout the Spanish Empire, and that's partly because different strains of the vaccine made their way into the empire, primarily through the slave trade and different parts. So, in one instance, you have the vaccine being documented in Buenos Aires through enslaved children who come up and make their way up through the South. In that instance, you have an enslaved boy who is transported to Lima, and the vaccine is introduced that way. In another case, you have samples of the vaccine from New Orleans and from Texas make their way through the north of Mexico. So there's these kind of multiple nodes through which the vaccine makes its way through, and these different campaigns are conducted. But we know the most about this mission that was known as the Royal Philanthropic Expedition of the Vaccine. And King Carlos IV agrees to sponsor this in 1803.
Edward Jenner's research and publications of his experiments traveled throughout the Atlantic world. Doctors in Europe and the Americas used the information in Jenner's book to try and find cowpox so that they could prove his experiments and implement vaccinations in their own communities. The problem for many around the world was that cowpox was a disease that was largely confined to cows in England and mainland Europe. So, to get the cowpox vaccine to European colonists in Asia and the Americas, doctors needed a pool of live hosts who could keep the cowpox virus alive as it made its way across the Atlantic and Pacific Oceans. The Spanish seemed to be the first to solve this problem by using both enslaved children and orphans to carry the disease and keep it alive as the Spanish brought the cowpox vaccine to the Americas. This was the premise of the Royal Philanthropic Expedition of the Vaccine, better known as the Balmas Expedition, which used about 30 Spanish orphans to transport cowpox in their bodies, on the order of King Charles or King Carlos IV of Spain.
King Charles of Spain lost several family members to smallpox, and he was horrified about it. He didn't wish that on anybody, so he was looking for ways to prevent it. In his empire, the Spanish Empire was Western Europe, most of what is now Latin America, with the exception of what is now Brazil, the Philippines and some islands in East Asia and some islands in the South Atlantic. And so he reached out to his physician, Javier Balmes, who was the royal physician. He was also very well connected with people in France and people in England. And they sent to him the Jenner paper translated to Spanish. And he goes to the king and says, look, this is some of the best stuff I've heard about how to prevent this. It seems legit. The king says, yes, go ahead. I command you to go through all the empire and vaccinate as many people as you can. And he gives them the funding, he gives them the ships, he gives them the manpower. Balmes is thinking, how am I going to get this cowpox from here to there? It's a few weeks to cross the Atlantic at the time. And so he uses a strategy from inoculation. Let's give it to somebody who will incubate it. And then when their blisters or their poxes come out, we'll take it from there, give it to the next person, and so on and so forth. So to do this, he recruits a group of about 30 orphans in La Coruña. It's a city in Spain.
It became common practice, particularly in the Spanish Empire, to incubate the vaccine inside human bodies. And so when practitioners would go to vaccinate, they would extract that fluid from different humans, from pustules that their bodies would form, and then they would spread the vaccine from person to person. The Spanish end up relying on orphaned children to actually incubate and play host to the vaccine, and that would require that the children be vaccinated every 10 days. So what it meant to vaccinate was to make an incision into the arm of someone who had not previously experienced smallpox, who did not already have immunity, and then you would take that lymphatic fluid or rehydrated scab material, and you would insert it into the incision, and you would wait for the incubation period to pass. You would wait for a pustule to form on that spot. So again, with vaccinating, you wouldn't have a rash that would cover your whole body like you would with smallpox. You would only have an eruption at the site of the incision. You would extract lymphatic fluid from one of these pustules from a patient, and then you would just repeat the process every 10 days with a new child. And so it really demanded this constant source of bodies, because once you run out of children, you run out of vaccine.
The expedition landed in Cuba, and they split up into two groups. Balmes will go on to Mexico City. The other group will go south into what is now Colombia in the rest of South America. The South American expedition lands in Colombia. They make it onto land. They go to different places in what is now Colombia, and then Bolivia, Peru, on south to Chile and Argentina. And along the way, they vaccinate as many people as they can. They pick up people so they can carry the virus to the next town over and go like that. Balmes continues to Mexico, and they are received by news that some other folks had already been talking about vaccination and have been attempting it as well. They take the orphans to all corners of what is Mexico and Central America and vaccinate different people. And then Balmes jumps on his ships again, and he gets letters from the Portuguese. They say, hey, can you stop at our overseas territories in Macau and what is now Macau, China? And he stops there. And the British also say, can you stop by Hong Kong and at least help out there too as well? And so he sends some of his people to Hong Kong. He stops in Macau. Then they get on their ships all over again, go around the southern tip of Africa, and they come around to some islands down there. There are British overseas territories, and stop and give vaccinations as well. And then they end up back in Spain. And the whole thing took about 2-3 years to go around the world vaccinating.
King Carlos IV's Balmas expedition did a lot to spread the cowpox inoculum and the practice of vaccination throughout the world. But as Nero mentioned, the early days of vaccination required a lot of bodies. It also came with some risk and some ethical considerations.
Technically, vaccinating was safer than inoculating, and advocates of the time certainly marketed it that way. But again, the question of risk really depends upon the specific circumstances. So they would spread the vaccine from person to person rather than just using the cowpox, right? You at that point risk transmitting any other diseases that person had, including something like syphilis. So that was an additional risk. And again, you're still asking the body to fend off a fever. And it became common practice again in the Spanish Empire to rely on enslaved Africans coming into different ports to produce that vaccine fluid on behalf of doctors, on behalf of the colonial state. And King Carlos IV, when he sponsors an expedition to bring the smallpox vaccine to the empire, one of the things that he demands, he passes this royal ordinance that says that parents have to give their consent to having their children vaccinated. And you actually see a great deal of effort on the part of colonial bureaucrats, on the part of priests, a number of different colonial officials to ensure that parents do have the option to refuse the vaccine. There's a number of different doctors who try to make vaccination mandatory, and you have colonial bureaucrats push back against that and demand that it stay voluntary. So in a sense, there is a concern that parents have the right to make these decisions for their children. And they don't necessarily frame that in terms of any kind of ethics that we might think about today in terms of medical ethics or even medical consent. The idea behind that had a lot more to do with the fact that parents had the right to make decisions for their children, and it was a particular legal right having to do with their position as parents. But again, that becomes really complicated when you consider the fact that enslaved people were used to incubate to produce this vaccine fluid. In many cases, it was enslaved children who were being used to replicate and incubate this vaccine fluid. And they, of course, were not given the option to consent.
The Spanish Empire spread the smallpox vaccine largely through overseas campaigns like the Balmas expedition. These expeditions used orphans and enslaved Africans to transport and produce the cowpox inoculum in their bodies. Now, as we heard from Farinero and Renee Najera, these expeditions brought the cowpox vaccine to the Caribbean and to Mexico. From there, the vaccine made its way to the Spanish colonies of Texas and New Orleans. But how did the cowpox inoculum make its way to the new United States? Did Americans resist the new smallpox vaccine as they had once resisted smallpox inoculation?
Edward Jenner publishes his study and his experiments on cowpox vaccination in 1798. And it arrives in America via some of these established networks between doctors. There's a doctor in Boston named Benjamin Waterhouse who had studied in London, made connections with some of the leading public health advocates in England. So he receives a letter first from John Coakley Lessen, one of the leaders of this movement. This is in 1799, and just sends them the publication. So Waterhouse learns of it first. He publishes it in the newspapers. Vaccination is wonderful. It does the same thing as inoculation. It provides immunity against smallpox, except the patient is not contagious. We don't have to quarantine them. So Waterhouse receives the first vaccine matter from England. He's the first one in America to receive it. And if it had gone to anybody else but Waterhouse, it would have been a better result. Because Waterhouse, despite being connected to these people that advocate for broad, public, free immunizations, the temptation is too great. Waterhouse, he's the only person on the continent, as far as he's aware of, that has the vaccine. And he realizes that he can make a lot of money from that. And he starts selling it to other doctors. They have to buy it from him.
As far as we know, the first strains of the cowpox vaccine that made their way to the United States came from England. The vaccine was sent to Benjamin Waterhouse with the hope that, like his colleagues in England, Waterhouse would use the vaccine material to make vaccination widely available throughout the United States and make it as cheap as possible to get vaccinated. But As Andrew Warman just pointed out, this was not the path that Waterhouse pursued.
Waterhouse establishes like a franchise system where doctors have to apply to him to get the vaccine material, and he's going to make money off of it. And if you agreed to Waterhouse's contract, you also had to give a quarter of all your future profits to Waterhouse. Other doctors start getting their own vaccines, but Waterhouse establishes that vaccination belongs in the hands of doctors, that it's a private kind of medicine. It's circulated between doctors rather than circulating it to towns or governors, where we've seen these huge inoculation efforts within communities. They hold town meetings, the community government establishes prices and regulations. Vaccination doesn't work quite that way. It goes between individual private doctors. And Waterhouse bungles some vaccine back in Marblehead, Massachusetts,
where the Balmas expedition vaccinated about 200,000 people throughout the Spanish Empire and the world. Vaccination got off to a really rough start in the United States, largely due to the greed of Dr. Benjamin Waterhouse.
Waterhouse is blamed for an outbreak of smallpox in Marblehead, Massachusetts, because the vaccine isn't effective, it doesn't work, and smallpox breaks out among people who thought they were immune for vaccination. And that's a huge setback early in 1800. So Waterhouse has turned a potential salvation into creating a really skeptical public. Other doctors blame Waterhouse. The public isn't quite sure what to think. It isn't adopted as quickly or as readily as it might have otherwise. Eventually, Waterhouse gets vaccine to Jefferson. It doesn't travel well. Jefferson kind of invents a technique where you would put vaccine material in a little vial and then get a bigger vial, fill that vial up with water, and put a stopper in it, and that would keep the temperatures from affecting it. It was clever. Eventually that works. Jefferson gets the vaccine and at first has a doctor vaccinate in his family and among his enslaved people at Monticello. And it's such an easy procedure. It's so successful for Jefferson that Jefferson starts performing a lot of these vaccinations himself. Jefferson sends vaccine material. You can gather it from the arms of people who have already been vaccinated and starts to send it on to other doctors. He sends it to doctors in Philadelphia. They send it on to doctors elsewhere.
Due to early mishaps and the great cost of Jenner's cowpox vaccine, the United States proved slow to adopt vaccination as a replacement for inoculation. But by 1809, there were efforts by Thomas Jefferson and towns in Massachusetts to see that vaccination both spread throughout the country and at least attempted to be affordable to all who wanted to be vaccinated.
There were charitable efforts to vaccinate. Vaccination takes over as the way to prevent smallpox fairly quickly, but access to it doesn't happen nearly as quickly. But there are some efforts that brew. After the Waterhouse scandals, there are towns in Massachusetts. The most well-known is a little town named Milton, Massachusetts in 1809. And Milton does a general vaccination. Everybody in town gets vaccinated. They establish a town charge. So in Boston, it would cost $5 to get inoculated, which is a high price. Milton says it doesn't have to be that expensive. We'll charge 25 cents a person. And anybody that wants to be vaccinated can be vaccinated for 25 cents. And they advocate for the state of Massachusetts to pass a vaccine law that would require towns to do this, that would require towns to do it in the same way Milton does. That is, establish a health department, do routine vaccinations each year, keep track of who's vaccinating, and charge 25 cents a vaccination. So nobody is put out because of cost. And there's a tremendous amount of enthusiasm around the Milton law. The governor, Christopher Gore, gets behind it. Lots of momentum. And Milton is sending out letters and pamphlets to everybody. They send it to every member of the House of Representatives in Boston. But ultimately, in the Massachusetts legislature, the Milton bill fails, even though everyone's behind it. Instead, Massachusetts passes the Vaccine Act, which was a version of it that advocated vaccination, said it was great if towns vaccinate, made sure it was legal that towns could vaccinate the public and charge taxes to do so, but it didn't require it. The Milton law would have required every town to do this. Now, it didn't require individuals to vaccinate, but it required every town to provide annual, cheap vaccinations. The new law that actually passed recommended that towns did it, but didn't have any enforcement mechanism. And so you still see smallpox epidemics into the 19th and 20th centuries.
Massachusetts has a long history of work in disease prevention. In 1721, Massachusetts was the first colony to try smallpox inoculation. In 1800, it was the first state to try smallpox vaccination. And even though the Massachusetts legislature failed to pass the 1809 Milton Law, a law that would have required all Massachusetts towns to offer low-cost smallpox vaccinations annually, by the mid-19th century, Massachusetts did pass a law that required vaccination for all children who wish to attend public schools. Today, vaccinations seem like a normal part of childhood for many. Although some parents opt not to have their children vaccinated, most do. And this willingness to vaccinate helped bring an end to the variola virus. After millennia of infecting humans, medical experts declared smallpox to be eradicated in 1980. And this raises an important question for us. 300 years after enslaved Africans introduced the world's first immunization procedure to British North America, how have we gone from smallpox inoculation to COVID vaccination? How have Americans' trials with smallpox inoculation, Spain's use of orphan and enslaved children to produce, incubate, and transport Jenner's cowpox vaccine around the world, how have these experiences played a role in leading us to the development of our modern-day COVID vaccine?
There's several phases or eras, as I like to call them. You have the inoculation era. When you see somebody who's sick, you get a little bit of their pustules and you give it to yourself. You also get sick, but maybe not as sick, and then you're immune. And you keep on doing that down the line to other people, and you build up immunity by getting a little bit sick. Then the next era is Jenner with his cowpox vaccine. So now we know that if we get something from an animal that is analogous to the disease in humans, it may provide immunity against the disease. So that goes on into the 1800s with Pasteur. The breakthrough with Pasteur is attenuation. Now you can actually give the virus that causes the actual disease, but you can attenuate it in a way that it doesn't cause severe disease or any disease at all, and gives you immunity for later on. The next leap in technology, which is the serum technology, you give a virus to animals, they develop antibodies in their body, you take out the antibodies in their serum, and you give that serum to people, and those antibodies help you get rid of the disease. The next leap occurs in the early 1900s when scientists figure out that viruses can be grown in some tissues. You can grow some of these tissues, or at least keep them in the lab if you have the right conditions, and you notice that the tissues break down because the virus is going through those tissues. And then you can use that as a vaccination. That takes us into the march of dimes towards the polio vaccine. And they use those techniques of growing it in the lab. Isabel Morgan, a researcher, she realizes that there's more than one strain of polio. So now it's like, oh, now we have to worry about other strains. So this is the next leap. We have strains of the same virus that cause different immunities, and you need to inoculate people against all three strains of the polio virus in order to prevent polio. The scanning electron microscope in the 1930s comes about, and now we can see viruses. We can see what they look like. We can classify them into different types of viruses, and we can test people for their presence. Then in the 1970s and 80s, the next breakthrough is we don't need to give people the entire bacterium. We don't need to give people the whole virus. We just need to give them a subunit of it. Our immune system is not reacting against the whole virus or the whole bacteria. It's only reacting against the antigens, the proteins on top of the viruses or on top of the bacteria. So let's just grow the antigens in the lab. Let's put the DNA for that antigen in the bacteria, and the bacteria will create that antigen, and we'll give people that subunit. then we move into the next era of genetics, because now we realize that if we could get some of that DNA or RNA from those viruses or bacteria into another bacterium to create those proteins, then why can't our cells do it themselves? Why can't we get the DNA or RNA of a virus and put it into our own cells? We can just grow it in ourselves. And that technology begins in 1990. It's the mRNA vaccine that we know now from the Pfizer and Moderna vaccines. Then there's a breakthrough in 2005 because now we can give the mRNA without our immune system ravaging it to bits before it can actually do anything. And we get to this day, we get to 2020, when they say, look, we've been trying this vaccine for cancer therapy, for hormone therapy. We know we can deliver mRNA to the cell. So your cell creates the protein and it presents the protein to your immune systems. We don't need to grow it in the lab. We don't need to put people at risk by growing a dangerous virus in the lab. And we arrive to this day when we have at least 2 mRNA vaccines based on that technology. The next leap is going to be personalized vaccines, where I can send a swab to a lab and they'll do my DNA analysis and they'll be able to tell me which vaccines and in what combination I should get to prevent disease for myself.
So how did we go from smallpox inoculation to modern-day vaccination? With a lot of trial and testing. It's a process that we've been able to see throughout this 2-episode series. During the Boston smallpox epidemic of 1721, Cotton Mather, Zebdale Boylston, and other Bostonians tested a procedure from ancient China and Africa that promised to help people build an immunity to smallpox by inducing a lesser case of the disease. And after years of testing and implementing inoculation, people were willing to test out and try Dr. Edward Jenner's observation that by taking cowpox into their bodies, a person could build an immunity to smallpox. And this brings us from inoculation to vaccination, to the history Dr. Renee Najera just shared with us. After years of testing with vaccination, we have new knowledge and observations that brought us to the present day, where we have multiple mRNA vaccines to help protect us from the newest threat to human health, the severe acute respiratory syndrome coronavirus 2, or COVID-19. And because of the strides made first in inoculation and then in vaccination, these new vaccines were developed in just under 1 year. This episode is part of a 2-episode series about the history of inoculation and vaccination, which is co-written and co-produced by Liz Covart and Holly White. You'll find more information about our guests, Renee Najera, Farron Euro, and Andrew Wehrman, plus notes and links for everything we talked about today, on the show notes page. benfranklinsworld.com/302. If you enjoyed this series, please support our work by becoming a Ben Franklin's World subscriber. You can join our subscription program at benfranklinsworld.com/subscribe. That's benfranklinsworld.com/subscribe. Production assistance for this podcast comes from the Omohundro Institute's digital audio team. Joseph Edelman, Martha Howard, Holly White, and Karen Wolf. Finally, are there any other short series you'd like us to produce? Let us know. Liz at benfranklinsworld.com. Ben Franklin's World is a production of the Omohundro Institute.